Sebagai salah satu penting, apa yang saya lihat adalah
Okay, good morning, class. Okay, we continue to the exercises 8.4. Okay, question number 2. Given this F, we need to find for the velocity, speed, and acceleration. Did you try that day after the class? Okay. Okay, velocity, that means F prime. Okay, F prime. Okay, differentiate F, we get velocity. Okay, I think this one shouldn't be a problem to you. Okay, differentiate F, you get velocity. Speed. Speed, that means the magnitude, of F prime. Okay, so we square, okay, we square this, -5 sine t square and 3 cos t squared. And we put them into a square root. So you get a 25. Okay, 25 sine square t. Okay, negative square, you get a positive. And 3 square, we get a 9 cos square t. Okay, we know that identity cos square t plus sine square t is 1. So this one, we can break this into this 25, we break this into 9 and also what's the value? Okay, this one we break it into 16 plus 9. this one. 16 plus 9 plus 9 cos square t. So this one is this is nine, right? It's a 9. Because this is an identity. When you factorize the 9, we have sine square t plus cos square t, which is 1. Okay? And we have the acceleration. Which is F double prime. Okay, so this differentiate this one. And -5 cos t. And -3 sine t. Then you get your acceleration. Okay. Any questions? Now we look at C. T sine t, t cos t. And t squared. Okay, the velocity. This one, we have to apply the product rule. Okay, product rule. Product rule.
Ini buat yang petak apa tahu produk kursi. Betul, ini buat itu bikin tapi media kita tidak buat produk ini. Buat yang fishing juga, produk. Fishing ini, dengan produk itu. UV
Okay, UV. So let's say you copy this, differentiate sign, you get a cos T plus. Now copy this one, differentiate this, you get a sine T. Okay, and this one, copy T, differentiate cos, you get a negative sine T plus. Copy cos T, differentiate T. Cos T and 2T. Okay, speed. So you need to square the T cos T plus sine T. Negative T sine T plus cos T. And 2T squared. Okay, we need to expand. If we're assigned by tenants. Okay, expand the T squared cos squared T plus 2 times this and this plus the square of this. Okay, same goes to this one. The square of this, you have T squared sine squared T. Okay, minus, okay, 2 times this one and this one plus cos squared T. And finally, the 4T squared. So here, 2T cos T sine T minus 2T sine T cos T, they are the same term. Okay, cancel out. Okay, this one, sine square T and cos square T is 1. Okay, 1. And this one and this one, we can factorize the T squared so that we have cos square T plus sine square T. And then plus the 1 is now plus 1 and this 4T squared. So we know that this is 1. So we have only T squared. Okay, so T squared plus 4t squared, we have 5t squared plus 1. Okay, then the last one, acceleration.
Apa dibagi loh?
Okay, differentiate product rule, product rule.
Hah? Tidak mungkin soal itu. 50.
Okay. Product rule. Copy, differentiate. Plus, copy, differentiate. Plus, differentiate sine t, we have cos t. Okay. Then, let's say copy, differentiate. Then copy, differentiate. Minus sine t. Okay, differentiate cos t, you get a negative sine t. And also 2 for the last one. Okay, so we can simplify. Well, Alex. Okay, any questions? Now we look at the last one. E. Okay, velocity. Differentiation. EP, 2E2T, and 2ET. Okay, next. Speed. And we need to square each of them. Okay, so square, that means 2 times T. Okay, 2 times T. This one, 2 square, we get a 4. E2T times 2, we get an E4T. Okay, 2 times 2T. And this one, 2 square, we have 4. ET, T times 2, we have E2T. Okay, then we can factorize. Right? We can simplify first. We have 5 E2T and 4 E4T. And we factorize the E2T. Okay, this is the square root of A times B. Okay, A times B. So this A, okay, this one actually we can write in this form. Square root of E2T times square root of 5 plus 4 E2T. Okay, this is actually equals to this. And this one, this E2T is actually ET squared. This is ET squared. So the square we can cancel out with the square root to get the ET. This one no changes. Okay, because this is ET squared. Okay, then finally acceleration. Acceleration, we just differentiate this one with respect to t. Et or into t and 2 et. Okay, any questions? Okay, next, we look at derivative groups. Okay, let U and V are the differentiable vector value functions. Okay, and this F, okay, this one, F is a scalar value function. Okay, this is a scalar function. U and V are vector value function. And C is a constant vector. Okay, constant vector, that means the vector contains only values. Okay. So we have the constant rule. Okay, constant rule means when we are differentiating a constant vector, we get zero vector. Okay, let's say you have 2, 3, 4. Okay, this is a constant vector. When you differentiate this constant vector, you get 0, 0, 0. That means zero vector. The first one, differentiating the constant vector, we get zero vector. Okay, if we have a sum of two vector value functions, then okay, it will be u prime plus v prime. Okay, this is the normal one, sum rule. And if you have a product function, okay, product function where it is a scalar function multiplied to a vector value function, then we use product rule. Okay, product rule, that means you differentiate copy plus copy differentiate. Okay, this is the what you have learned, okay, for product rule. And if you have a dot product, okay, dot product, then we can apply the dot product rule. Okay, whatever multiplication, that will be dot product. Okay, just like how you use this. Okay, we are applying the product rule, but the multiplication, it will be dot product. Okay, so differentiate, we get u prime, copy v, but here we use dot product. and then plus, now copy this, differentiate this. Okay, U B prime, but in between, this is a dot product. Okay, similar applies to the cross product. When you have a cross product and we want to differentiate this, okay, so let's say you differentiate first, U prime, and then copy V. And in between these two, this is cross product. Plus, now copy this, differentiate this. Okay, in between, this is a cross product. Okay. Now we look at this example. Compute this one where you are given the ft as 2t and the vector value function, okay, is 2e2t, 3t, and sine t. Okay, we want to compute the differentiation by using product rule. Okay, so this one, the formula is f prime u plus f u prime. So you just differentiate accordingly. F prime is 2, u just copy u, and then plus copy ft, which is 2t, differentiate u. So differentiate this one, we get this. And after that, we simplify, combine, and we get the final answer. Okay, but of course, if you find the product first, then only you differentiate, you will get the same result. Okay, this one, dot product rule. Okay, dot product rule. So this is the formula. Okay, u prime. Okay, u prime v plus uv prime. In between them, we use dot product because this is dot product. Okay, so u prime, you just find for u prime dot v. Okay, this is from your v. Okay, from here plus u dot v prime. Okay, so for the dot product, remember for the dot product, the output will be scalar function. So cos t times cos t, you get a cos square t. Negative sine t times sine t, you get minus sine square t. And 2 times 3t, you get a plus 6t. Okay, and then plus the dot product of these two, you get this. Okay, there is no more ijk or the bracket to represent the vector value function because this is no longer a vector. This is a scalar function because of the dot product. Okay, and finally, simplify this, you will get this. Okay, and the last one, okay, cross product. Okay, so if we have a cross product and we want to find the differentiation using cross product rule, okay, this is the formula. Okay, so you find for the u prime and v prime respectively, put them into the formula, and you just compute for the cross product. Okay, compute for the cross product, you get this, and then plus compute for the cross product, you get another vector. Okay, and then vector plus vector, you get a new vector. Okay, now we look at this exercise. Okay, compute the following derivatives. Okay, this one we use product rule. Okay, product rule. This one also product rule. Okay, for number 2, this is a product rule. This is a dot product rule. This is a sum rule. Okay, this one we use a product rule. Okay, product rule. Let's say we copy. Okay, let's say we copy this, and then we differentiate this one. Okay, differentiate this. It means that you get a 1, negative 2t, and negative 3t squared. Okay, copy, differentiate, plus. Now differentiate, copy. Okay, differentiate, you get a 6t squared. Okay, differentiate, copy, copy, this one. So you expand and sum up. Okay, sum up the two vectors into one. Okay, number 1A.
Yeah. How do you get E power W equal to vector 2D minus x2
This one.
ah
Okay, I copy, differentiate, and then plus, differentiate, get this one, copy. Product. Okay, for question B, we write the t squared minus 1 square root into the form of t squared minus 1 to the power of half. Okay, because we want to do the differentiation later, this one will be easier if you present it in this form. Okay, try to apply the product rule. Copy, differentiate, plus, differentiate, copy. Okay, so let's say I copy first. Okay, copy, differentiate, plus. Now differentiate this one. Okay, differentiate this one goes to the front. And then this one minus one, right? Differentiation minus one times differentiate this one, you get a 2t. Okay, so this is the differentiation for this function. Then copy this. Okay, then this one we can simplify. Okay, we can simplify and we want to factorize. Okay, we want to factorize. Okay, but these two are different. Power is different, but the function is the same. T squared minus one, t squared minus one. So if we want to factorize t squared minus one, what is the power? You will take half or negative half. We want to factorize this function. You will take the power of half or negative half. When you have x squared y plus x cubed, let's say, okay, this one. You will factorize x squared or x cubed? X squared. Why you factorize x squared? Because the one with the smallest power is 2, right? Which one is smaller? Okay, so after we factorize this, okay, here no changes, 1, 0, 2 plus. Okay, this one, sorry. This is negative, this is positive. So this one, after you factorize negative half, what is the new new power for this function? What is the new power? Half minus negative half. 1. Half minus negative 1. Just like you do the factorization, whatever you take out, you minus x squared. Okay, this one y. This is different from this. So we use the 3 minus whatever you have factorized. 3 minus 2, that's why you still have 1 here. Same goes to this one. This one, you have factorized the negative half, so you need to use this one minus negative half. So you still have 1. Just like when you do the extension, this 1 times this, that's mean negative half plus 1, which is half. Okay? And 102. Okay, plus. Okay, this function has been factorized. And we have the t, so this t we leave it to this vector value function. So t times into this. Okay, then this function multiply into the vector value function. So this one times 1, t squared minus 1. T squared minus 1 times 0, 0. T squared minus 1 times 2. Okay, combine. Okay, vector plus vector. The t squared minus 1 plus t squared. 0 plus t. 2t squared minus 2 plus 2t squared. Okay, next, number 2a. 2a, use the product rule. Okay, your ft is sine ti plus 40 squared k. There is no j. That's mean component function of j is 0. Okay, use the product rule. Okay. Okay, product rule. For B, differentiate as differentiate for B. Okay, we can factorize the E2t. use the dot product rule for B. Dot product. Okay, copy, and then dot differentiate. Okay, let's say we copy first. Differentiate. Plus differentiate. Copy. Okay, so product, that means this one times this plus this times this plus this one times this. Okay, so sine t times sine t sine square t. 0 times 0, okay, 0. 4t squared times 2, 8t squared. Then plus cos t times negative cos t minus cos square t, 0, and 16t minus 8t. So this one is simplified. Okay, simplify, we get a sine square t minus cos square t plus 8t squared plus 8t. One. And we copy, differentiate, copy, the given answer is 34t squared. Times 16. Oh, yeah. T squared Okay, sum through. Okay, so you need to differentiate before minus. Any questions? Okay, so we have done the syllabus of big 12. Okay. Can we continue to the syllabus of week 13? Yes or no? Next week is week 13. This week is week 12. We have done the week 12 syllabus. Okay. If you want to, if you do not want to continue this one, then we will look at this in the next part, which is Thursday. Okay, since we have some extra free time, let's look at some of the past year questions. Okay, we just go through. Okay, go through. See what kind of question from this chapter. Okay, this is from 1920. Okay, 1920. Sorry, I forgot to read. Okay. Okay, so if you look at the past year question, you see question number 1 is about what is this? Interpolation. Okay, interpolation. Newton interpolation to construct a suitable Newton interpolating polynomial. You are given this, okay, and then compute for the p raw when this independent variable is 50. Okay, this one suitable Newton interpolating polynomial. Actually, here it doesn't tell you what is the order, right? Okay, so we will use all the data. Okay, we will use all the data to construct for the Newton interpolating polynomial. Okay, next one, B. Okay, this one is about Lagrange. Okay, Lagrange. So given log 4 at 4.5, log 5.5. If you are given this kind of figures, you know that this is your x, this is your y, right? X, y, you are given 3 points. Then compute for log 5. Okay, meaning that you have to construct for Lagrange polynomial of order 1. Then you estimate for when x is 5. Okay, this one, order of 2, estimate the same thing. And if the true value is given, then discuss the answer in part 1 and part 2. Okay, through the calculation of absolute error. Absolute error, we just use the true value minus the approximation that you obtain from part 1 and part 2. And of course, the second one, for sure, it will give you the lower absolute error because the order is higher. Okay, so with the lower absolute error, it gives a better approximation. So you see, this is question number 1. This is year 2021, okay, the next year. Okay, so similar, see, Newton interpolating polynomial. Okay, so you are using all the points to construct for this Newton interpolating polynomial. Then estimate when x is 750. Okay, 750. Okay, this one, Lagrange again. So given the function, and you have the x, that means you need to find for the corresponding y values. Then compute for the Lagrange polynomial of order 1, estimate for this one. Then the second order, estimate for this. Okay. Then discuss the result through the calculation of, okay, this is percent relative error. That means we are using the true value. Okay, you are given the true value. So true value minus the approximation divided by the true value times 100%. You see, formula is not given. You have to know the formula. What is the formula for the absolute error and the percent relative error? Discuss your result. Okay, discuss your result. Okay, then the next year, 21, 22, okay, 2021, 22. Again, okay, this is Lagrange interpolating polynomial. Okay, C2, this one, C2. 2 means order of 2. Okay, order of 2. This is order of 3. Okay, C3 means order of 3. So you just compute for the second order and third order of Lagrange interpolating polynomial. Then estimate when x is 5.8. Okay. But of course, you have to know which point to choose. Okay, because you are given this 4 points. For second order, how many points? Second order, how many points? Yeah. 2 points means straight line, first order. 3 points, 1, 2, 3, or 1, 2, 3. The quadratic second order means 3 points. Okay, second order, we need 3 points. So 5.8. 5.8 is here. So you need to use this 4, 5, 6. Okay, you have to know how to choose the correct points to use for this estimation. Okay, for the construction of the interpolating polynomial. Okay, then this one, third order, we have to use all points to construct for the Lagrange interpolating polynomial. Okay, for this year, okay, use the power method. Okay, power method. Nothing's new. Power method show that the linear, okay, this one show the linear system is strictly diagonal dominant. Okay, strictly diagonal dominant, that means modulus of 7 is greater than modulus of 1. This one, modulus of 7 is greater than the modulus of -1 plus modulus of -1. Okay, I hope you still remember how to show the strictly diagonal dominant. This one is modulus 7 is greater than the modulus of -1. Okay, okay, so this is question number 1. Now we look at the last year. Okay, last year. Okay, Lagrange. This is similar to the previous year. Second order, third order, is it the same one? Same one. Different. Oh, different values. Different values. Okay. Gauss-Seidel. Okay, this one is Gauss-Seidel. Initial point is 0, 0, 0. Okay, so I think this one shouldn't be a problem. Huh? And then power method. Again, power method. As usual, you are given the initial value 0, 1, 0. Okay, this one, I think all of this you can try. Then we look at question number 2. Okay, question number 2. See, this is about the numerical differentiation. Numerical differentiation. OH. Okay, first derivative. Okay, first derivative. X is 1.5. Step size is 0.5. Using forward and backward with accuracy of this. So you need to find for the formula. Formula is given, but in this form. Okay, in this form. So you have to know which one is OH. Which one is OH squared? Which one is OH power of 4? Okay, so you can refer to the past year appendix. Okay, then you know which one is the first order because you are given know that this is for first derivative, first derivative, first derivative. Okay, this is also first. Okay, so this is OH. This is OH squared, right? OH squared, OH squared, OH squared. This is OH power of 4. Okay, you have to refer back to the notes. Question number 2. Okay, then you know which formula to use. Then next one, this is also a numerical differentiation for second order. But this one involves the analytical method. Analytical method means we differentiate. We differentiate the function. This is 4 times 2.2. You get an 8.8 x to the power of 3 and so on. That is analytical method. Okay, analytical method. Okay, numerical method. This is numerical method. Okay, so high accuracy standard difference approximation of second order derivative. Okay, so find for the correct formula. You see how many marks? 10 marks. Okay, so that's why I say numerical differentiation and also numerical integrations are the easiest topics to be scored in final exam. These 2 topics. Okay. Calculate the approximate percent of relative error. Okay, you see formula is not given. You have to know how to find for this. For the solution obtained in 1 and 2. Okay, so from 1, what you obtain is the true value. From part 2, what you obtain is the approximation. So with these 2 values, you can calculate for the percent relative error. Okay, or just calculate, no discussion. So just calculate. Okay, then the following year. Okay, this is the hardest one. This is as what I mentioned, and we have discussed in the class. Numerical differentiation. Okay, then the next year. This is also numerical differentiation. Okay. I is given didt. Okay, that means we need to find for I prime. Right? We need to find for I prime. So how to get an I prime? We use numerical differentiation. Okay, I prime, that means first order. So use the standard difference formula to estimate the voltage drop. This is the voltage drop. We want to estimate this. So L is given, L is 1. Okay, L is 1. And we need to know what is the I prime value. So the I prime value, I is given, your I prime value will be approximated using the numerical differentiation. Now I just give you a rough idea so that you can try, you can start to try, okay, and discuss the answer among your friends. Okay. Okay, next one, given that, okay, didt, okay, this is the, you can get the true value from here. Calculate the voltage drop at t equals to 10, okay, when inductance of 5 and correct to 3 decimal places. Voltage drop. So you are given this voltage drop. So you just need to use the L multiplied to the I prime. Okay, you are given I prime here. Just substitute the values. Okay, 6 marks. Very simple to get 6 marks. Then that means what you obtain here is the actual value, and you can calculate the actual value. You can calculate the percent relative error based on the actual value and the approximation. Okay, to get this. Okay, and last year, see, similar numerical differentiation. Okay, you are given this table. We want to find the velocity when t equals to 3. Sorry, this is type 4. This one should be 0.3. Okay, this one should be 0.3. Using standard difference approximation scheme with the step size. Okay, that means you have to find for 2 answers. Okay, because you are asked to use different step size. Okay, t equals to 0.3. This one, 0.3. Velocity. Okay, velocity. So what you are given here? Distance. This is distance. Velocity means first order. Okay, first order. Then next one, velocity of the slider when t is 0.35. Okay, 0.35 is in between. Use the standard difference approximation. Okay, try first. Then construct a derivative for the following function. Okay, this is analytical. Okay, analytical method. You just differentiate the function. Okay, this one also differentiate the function. And this is composite function. Composite function, if you are given f and g, okay, determine h prime, where h is f gx. Okay, f bracket gx, that means gx, this function, you have to substitute into this x, that means into this x. Okay, then only you find for the h prime. Okay, try first. So this is for last year. Okay, question number 3. Okay, question number 3, this is numerical integration. Okay, numerical integration. You are given this, where are you? Okay, you are given the function. You want to integrate this. So solve this using Simpson's 3-8 rule with 12 subintervals. Okay, this one shouldn't be a problem. Just define whether this can be solved using Simpson 1/3 rule. Yes or no? Simpson's 1/3. With 12 subintervals. What is the condition for Simpson's one-third rule? The n must be in multiple of 2. Even that's been 2. Multiple of 2. Is this in multiple of 2? Yes. So the answer is yes, because n equals to 12 is in the multiple of 2. Okay, very simple. 3 marks. Then solve B. Okay, B, this one you have a square on the fx. Okay, you have the square on the fx. So that means in your table, all of your f values, you need to square them before you allocate them in the correct columns. Okay, this one, it used the one-third rule. Okay, Simpson's one-third with 10 sub-intervals. Okay, this one shouldn't be a problem. Just define whether this can be solved using Simpson's 3/8 rule. What is the condition criteria to use the Simpson's 3/8 rule? It must be, n must be in multiple of 3. Is this multiple of 3? No, the answer is no, because this is not in multiple of 3. This is the justification. Okay, so this is question 3. Okay, next. Question 3. Okay, calculate the integral, okay, using tabular method. Okay, this one, tabular method, you have learned how to find for the integration of this using tabular method. Then B is numerical integration. Okay, numerical integration. You are given this one from 0 to 8 using Simpson's one-third rule. Step size h equals to 1. Okay, this one shouldn't be a problem. You are given all the data here. Just construct a table, get the values. Okay, trapezoidal rule also no issue. Okay, identify which one is the best method to approximate the integral by comparing the result, okay, of this and this with the true value. Given the true value is this one. So we just find for the error or for the percent relative error. Okay, and give your answer based on that. Okay, this one, the area of P is estimated using numerical integration with one segment, which is n equals to 1. Okay, only one segment. So suggest which method do you think would give better area approximation? The trapezoidal rule or Simpson's one-third rule? Based on this one, what do you think? Trapezoidal rule or Simpson's one-third rule? The answer is Simpson's one-third rule. You have to know what is the reason behind, what is the idea behind the trapezoidal rule. Trapezoidal rule is estimate the area by estimating the area of trapezium. Okay, the area of trapezium is this one. But for Simpson's one-third rule, we will estimate the area under the curve by estimating the area under a quadratic. We are interpolating 3 points to get a quadratic curve, right? Then we estimate the area under the quadratic function. So this one, this is more to a quadratic compared to a straight line. So this one, Simpson's one-third rule will give a better approximation. The next one. Okay, solve this using integration by parts or tabular method. Okay, no issue. This one, using substitution of this. Okay, this one you have already given the hints. When you want to integrate cos square, we can't integrate cos square directly. That's why you need the identity to change the cos square into cos 2x. Okay, after you change, then you know how to proceed. Okay, the electric current. Okay, determine the total charge using Q. Okay, Q, we want to determine this one. This means we want to integrate this, okay, in 30 milliseconds. That means 0 to 30, and this is the function. Doesn't mention which method to use. The total charge passing point. Oh, okay. This is not numerical. This is not numerical. This is analytical. You just integrate. Okay, integrate this function from 0 to this 30 milliseconds. Okay, and then last part, this is the numerical integration. Okay, you are given the function, integrate from 0 to 0.8 by using two different groups. Okay, h and n. Okay, this n is the same as the capital N, the number of subintervals. Okay, last year, question number 3. Okay, volume is given by this formula. Okay, this is F squared. Okay, F squared. So you need to compute the volume using Simpson's 3n rule. And table 3 is here. Okay, so this one shouldn't be a problem. Okay, this one, do not forget about the pi. After you find for the integration and approximation, then you need to multiply the pi to get the volume as your final answer. Then calculate the actual volume. Okay, actual volume if function is sine x, meaning that here this is sine square x. You need to integrate from 0 to 3. Okay, from 0 to 3, integrate sine square x. But we can't integrate sine square x directly. You have to use the identity. The cos 2 theta equals to 1 minus 2 sine square theta. Okay, change into cos 2 theta before you integrate. Then you will get the actual value. Okay, and finally, determine the percent relative error based on the value from the actual and the approximation. Okay, similar question. Then the last one. Okay, last one. You are given F and G. Calculate all this. Okay, I think this one shouldn't be a problem for you. Okay. And this one, this will be covered under week 13. Okay, this is under week 13. Okay, and also week 14. B and C under week 13 and 14. Okay, we will look at them after week 13 and 14 done. That's reverse is done. Okay, this one, question number 4. Okay, the path is represented by this curve. Compute the velocity. Okay, this one you have learned. Compute the velocity. So you need to find for r prime and then substitute the t equals to pi over 2 to get the velocity vector. Okay, acceleration. So you differentiate one more time. Okay, to get r double prime. Okay, after you differentiate, then only you substitute the t. Okay. Identify t when the object's acceleration is orthogonal to its velocity. Okay, that means the output of part 2 is orthogonal to output of part 1. Okay, orthogonal. Orthogonal, what is the relation for orthogonal? Dot product or cross product? Okay, you haven't started to do your revision. This one I leave it to you to figure it out. Dot product or cross product. Then find for your t. Okay, this one, this is under week 13 and 14. Next one. Okay, so you see, this is what you have learned today. This is F double prime. Okay, F double prime, then substitute t equals to 1. Okay. Differentiate twice, then substitute t equals to 1. Okay, this is the dot product. So after you dot F and G, substitute the T value. Okay, this is a particle, okay, a curve. Point P is the distance of this one. It is along the curve from the origin. Okay, this is with 13 and 14. Okay, so you see, this is what you have learned today. T times F prime. So find for F prime, then multiplies to T, the vector multiplies to T, and finally substitute T equals to 1. Okay, this one, find the dot product first. Okay, find the dot product. If you get a scalar function, then you integrate the function from 0 to 2. Okay, that's it. So now roughly you know what kind of, what are the topics it will be covered under the final exam. Okay, starting from the interpolation down to the numerical differentiation, numerical integration, including the differentiation and integration. Okay, then the last chapter. Okay, the last chapter. Okay, so I hope you can try the question first. Okay, so today we end our class here, and I will see you on the first day. Okay.